Hello everybody, we're going to be working on Unit 1 tonight, and I'm going to begin by going into the unit, and I'm going to be pulling down the publisher's PowerPoint that I have embedded at the top of the unit folder. See, it's kind of taking a little bit of time to load. And if you had already looked through this material, I do want to point out that I've added a couple of things here in Unit 1, mostly for reference, even though it is after the fact. I know that last time when we went through the install for SQL Server, we were working off an instruction set that Christian had created for us. And for the most part, it was pretty spot on. But then I discovered in the aftermath that there is a chapter 10 in our book, which also leads to several online chapters from the author. And that chapter is really designed for people who are working with different database systems. So for example, if you're following through the book, the product that they're recommending that you use as a database front end is Microsoft Access. And truth be told, that is a fine product, and we could teach the whole course around it. But out in the field, people tend not to use that product professionally, especially on the enterprise level. So that's why I'm pointing out where you can get the information. The other nice thing that the author has done is they realize that depending on where you work or what you have access to, you might have access to Oracle, or you might have access to MySQL and SQL Server. So he's providing resources on how to install and work with those products. And in some cases, there's really slight differences in the SQL commands that go with it. So that's kind of a thing to know. Those differences are so subtle that for the most part, everything we take out of the book should work just fine. But I think there's a couple spots where we might run into issues. But the chapter 10 material is provided specifically for that reason. So I have the PowerPoints that come with, and then if you're so inclined, you can go to the publisher's website and pull down some of the information. And so I included those two PowerPoints here in just a little blurb about the related materials. The other thing that you'll notice is if you go over to the resources page of our course shell, and I think this is important, and I realize this will kind of evolve over time as the course evolves, but I do have these textbook resources here, and I know that we've already explored these two items here because we needed to in order to get our products installed. And just remember, if you do want to use Microsoft Access, it is part of Office 365, but you want to use the downloaded and installed version. I don't know if they have a 365 version like ones in the browser. I doubt it, because that's a pretty complicated product. I also added one additional file here with the textbook resources that you'll probably notice, and that is a zip file that contains all the student data files. Now what that means is that all the databases in all the formats for all the chapters. If I remember right, they have like 4 or 5 databases that they use throughout the textbook, and the author provides them in each one of the major database formats. So that would be Access, Oracle, SQL Server, and MySQL. So if you want to be adventurous and do all your work in MySQL, I wouldn't prevent you. You can still do all the stuff in one of those other products, but you have to make sure that you are pulling down the right files. Okay. And then I have little descriptions below. Now, if you bought the textbook, formally from the bookstore and you have like a hard copy, sometimes it comes with an access code, but if you peruse the preface and the introduction, you'll notice that they do have online resources for students as well. That's where these data files come from. So I just did you the courtesy of downloading them for you, and the PowerPoint so that you don't have to and go hunting for them. Now I'm in the Pearson website fairly often, and Pearson, along with a lot of other people, have these like auxiliary online products they always want you to buy, and not that they're not wonderful, but it's like we need to spend more money. I don't think so. Right? But I do, I wouldn't prevent you from doing that if you really want to spend the money, but I really functionally don't see the purpose unless you have an intent of being a serious database developer and need access to that. All right. Meanwhile, let's get rolling on the chapter 1 PowerPoint here. So I have it already pulled up. And as I said, I am going to be kind of rifling through this pretty quickly. They do state the learning objectives here, just a really quick overview of them. And let's just go ahead and start digging into the material now. All right, so first they start with a little bit of computer history. I'm assuming that all of you have probably been in some class where you got a little bit of this. Is that a safe assumption? I know, Keegan, you were in my IT and business class. We actually talk about it pretty heavily. But if you guys did not, I usually do like a whole spiel on this. I love computer history because I think it's fascinating, especially how far we've come in so little time. But I would implore you to investigate these things. But they're trying to give you a background here, and like, how did we get to where we are now with the technology that's been developed? And now they cite here the first personal computers, and you know what? They list the Apple II and the IBM PC, and those weren't the first personal computers, but they were probably the most important ones in terms of milestones. So yeah, the Apple II, so what happened to the Apple I? You kind of get the point, right? And there were other personal computers aside from Apple. Does anybody know like what the first commercially available personal computer was? Nope. The Altair Basic, right? And back in my office on campus, I actually have a magazine that's got like ads for it from back in the 70s, so you can see what it looks like. And there's no screen, no keyboard, no mouse. It's just switches and lights, and you would have to program it, right? Eventually, they got the machine to the point where it could support those, but by then, you know, the Apple people had built stuff in the garage, and then IBM quickly followed. But notice how long it took IBM to catch up, to put out a personal computer. Nobody's going to want a computer at home. Wrong. Everybody's got one in their pocket, so that's a big thing. The other thing that happened is they developed networking. So that really goes right along with the development of the Unix and Linux operating systems back in the late 60s and early 70s. But people were working on interconnectivity of computers since the early 60s, and it really kind of took off, you know, by the time we got to the mid-70s and then early 80s. All of a sudden, not only did we have an internet going, but we had actually several rival networks that kind of ended up kind of combining to really form what we know today as the internet. So it's a combination of public and private resources. Parts of the early internet I think are really fascinating is that they were actually ran over phone lines predominantly with dial-up. But regardless of that, it was kind of a hack. It was a workaround of what the existing system was. It wasn't the always-on technology that we know. They just connected when they needed to. But they still did all the same things that we do today. Email, chat rooms, surfing, kind of in a different way, but you know, they would do all those things. And I think it's fascinating. They talk about the ARPANET, and you know, you should always understand that the government and the military are really big into putting a lot of money into these advanced technology projects, and it was really government investment that really made the internet happen. So if they weren't looking for ways to connect things up, maybe it would have been delayed another 10 or 20 years, who knows. I would think probably not, because once you have computers, you know, say if you can't connect them, what's the point? The World Wide Web really took off in the mid 1990s, and I would say 95 is really the year of the explosion, although we were doing internet well before that. Late 80s, early 90s, in academic environments, we would FTP and Telnet and remote login and all those things. But the browser is really what opened it up. They initially had what we called text-based browsers, and then in 1993, actually a little bit earlier than that, they came up with the Mosaic browser, which you guys probably learned about in Web 1. Although now I've had a couple students in my last Web 1 class contest that Mosaic was the first browser. They're saying that there's a couple others that did it first, and you know, it's all kind of a matter of debate. But Netscape is considered the first commercially available browser that consumers were using, and it was based directly on Mosaic. The same people that developed that product created Mosaic. And I always like to say It's Wisconsin people that developed the first browser. They just happened to be at a school in Illinois, but it was two guys from Wisconsin going to school down there that did it. And I think that's really kind of cool when you think about it like that. When we got through that initial like personal computer era and the internet started to take off, then we entered into this era of what we call Web 2.0. Do you guys know what defines Web 2.0? What? Say that a little louder. Well, I'm asking, what does the phrase Web 2.0 stand for? I mean, what different? If there was a Web 2.0 in 2000, what was Web 1.0? It's kind of yeah, and it's not really that significant, I suppose, but I think of it as being pretty significant because that's the era where prior to basically the early 2000s, when you used the internet, you were a passive observer, kind of like reading a static textbook. You'd go in there, you'd read, flip through the pages, look at the stuff. Wow, that's great. Maybe follow a link and go somewhere else. When Web 2.0 happened, interactivity is really what happened. People changed from the role of just being a passive consumer of the information, so being a reader, and to the point where they also became an author and a reader. So you think of all the social media revolution, blogging, all those things are really what we're talking about. So now even when you go to a newspaper site and you read an article, you can log in and drop in comments and get whole conversations going. And it really changes the meaning of the story, because all of a sudden the public is contributing to that. So I think that's a fascinating thing. But we think of that really as kind of like the explosion of the social media era and the fact that everybody can put their stuff out there, not just people who are in the know. So they talk about the smartphone. Okay, so it's 2007. I always think in my brain that it's 2009 with the first smartphone, but it's still not a really long time. It's a little over a decade, and we have almost, at least in a country like this, almost 100% adoption by every adult who has enough money in their pocket to drive a car, pretty much can afford a phone. Fascinating. Then we also have the tablet thing that really changed a lot how we interface with the world of technology, primary computing platform folks. And I was at a meeting this afternoon here on campus. We were talking about computer literacy competencies as a core competency for the college and how it should really be changed to digital literacy and what that all means. And we made the point that in the past it was about using a computer. Now is it? I mean, because so many things are computers, so it really kind of blurs things. Now, the fascinating, final bullet of this little sequence of history slides is all of these examples depend on databases. So at the heart of every operating system is a database, if you guys aren't aware of that. A lot of the applications that we use, whether they're loaded on your machine or on the internet, are driven by a database on the back end. We Google things where the search results come from. Right, they come from a database. And databases are pervasive and they are important. So they give examples here. So look at these really popular sites. Facebook, Twitter, any site that has social media, right, where you are posting things and interacting with people. The only way that you can really functionally store that information and then have it cross-reference a million different things is through a database. Facebook, for example, if you're curious about the initial technology, it was built on top of a MySQL database with PHP on the back end. A project for Mark Zuckerberg. What's really funny is I was watching, I forget what movie it was, but they had this thing where they transported to hell and Mark Zuckerberg was the IT guy. Oh, that was on Saturday Night Live. And Mark Zuckerberg was stuck being the IT guy in hell. And it just really made me chuckle. Probably pretty fitting, honestly. And Amazon too. Any big e-commerce site has to be driven on top of the database. It's really kind of the only way to make it happen. So they go through these silly slides here. How do you search a database? Well, you can bring up a Google screen, right? And you type in what? Search criteria. There are some people that realize that with a Google search window, you can actually do things with it. Like you can put plus signs in and minus signs in and tell it to search certain websites. And then you can use all the tools to filter it. And really what you're doing, folks, is you're building a query for a database. Simple as that. In its most primitive form, I find it fascinating. You just type words in and get such great results. And of course, they're using the Pearson website here, the publisher, to demonstrate like online searches. But many websites now also have built-in search mechanisms. All right, let's talk about what we're here to learn, and that is databases. And it says the purpose of a database is to help people track things of interest to them. Sure. For the Nazis, it was where all the Jews were located, right? And who knows what it is that is of interest to people, but most companies, they try to keep records, right? And in the old days, we'd keep records on paper. And if you look at just financial records, you'd have accountants who would keep ledgers. And a ledger book would have things for like sales, expenses, who knows? And it would be many different pages. And sometimes those pages were interrelated. And that's a really great example of how a database works. So sometimes you'd be looking at a line item in a ledger, and it might have a cross-reference to a different page where you can actually look up what the item was, all the details of it. And those separate sheets in a ledger might compare it to something like a table. Now a table is, as it says, rows and columns like a spreadsheet. And we also sometimes call tables, depending on the platform you're working in, sometimes we call those files. In fact, we call them flat files. 2 dimensions across and down, 2 files, a flat file. So really, I always like to think of like one of the fundamental building blocks of a database is the fact that we use tables, like a spreadsheet. And if you're the kind of person where, let's say you have it in your mind to do something, you're the kind of person that either goes to your phone or a piece of paper and starts jotting down a list, you're building a database. That's the way I kind of see it. So that's where it stems from. Databases, unlike plain old spreadsheets, have the capability to have multiple tables, and then, as it says, where each table stores data about a different thing. And the first thing you might say to yourself is, why? Why would I put that in a different table? And that is to make the data as efficient as possible. So as we kind of plow through the book, you'll learn about this thing called normalization, and there's different levels of it. And it really is to make the data more efficient. There's no reason why I need to have a database table for students that every table related to a student has all their personal information in it. It's silly. You keep it in one table and link to it. That's the point. It says each row of a table stores information about an occurrence or instance. And honestly, I always think about it as kind of like maybe related to a single entity or a single transaction. A single thing that happens would be each row in the table and all the data that goes with it. The database also stores the actual information, so it's not just all the connections, but all the actual data, and then how the data connects to each other, which is the relational. And the relational thing becomes a pretty big issue pretty quickly in databases. They have a couple of interesting diagrams here, and you know what? I don't want to spend too much time on them. You can look at them yourself, but they're kind of making the point that you can look at a database with your phone as much as you can with a computer, because they're both computers, right? The interfaces are a little bit different, but absolutely, it's just a matter of how you're getting there. So the data network for a cell phone basically is the internet, right? And you guys, are you guys watching a lot of the playoff football out there? Maybe, maybe not. Are you guys noticing all the commercials that are coming out now about 5G? Yeah. Now, I don't know if anybody around here has 5G phones yet. I certainly don't. But this corridor here, we're seeing Kenosha County going up to Milwaukee. Right along the interstate is a big 5G development spot. Thank you to Foxconn and some others. But they are planning and rolling it out really soon in this area. So I think that's kind of fascinating to know. All right. Now, they do have some conventions they use in this book, and you can read this as much as I can, but they tend to use all caps when they're using table names, and column names tend to be in what we call camel casing, but starting with a capital letter. And is that something you must do in a database? No, but you will find in many organizations they do follow conventions, either exactly like this or not, and there's reasons for it. Why might they put an underscore in? Because that's just kind of the convention that database people use. And if you put a space in, guess what happens? It doesn't work. In many cases, depending on the database that you're working with. They're going to have examples of like working with tables, and I know that we'll look at this more when we actually get in there. But here's the example where the table name is in all caps, and then each one of the column names is in camel casing. So if they're saying email address, the convention is capital E, capital A, no spaces or underscores. Do you have to do it that way? No. If you were designing something from scratch, you could do it your own way. But what is helpful in many languages is if programmers are following conventions, let you stick with them, and then you can quickly tell by looking at a piece of code what it is. It's a table. Oh, it's a column name. I can just tell by the way it's formatted. So to me, I think that's really kind of useful to know. All right. They give examples here of various tables and why we start to split data apart in a database. So like, for example, I mentioned before, if I have a student table that has all the students' personal information, and it might include a whole bunch of other stuff like address, phone number, etc. And then, students need to take classes, and then they also earn grades. But I can't just have a table that indicates, what class somebody is taking without the ability to also link it back to who's taking it. So what happens in databases is we end up forming what we call relationships. So the section number or the student number in a grade table needs to tie back to an actual student record. We don't need to put the grade information in the student record. That's wasteful of space, right? So we'll look at how we organize the database to make it more logical, basically. But those relationships are really what drive databases. And I think it's fascinating, the book does name the person who came up with this, and I think it's coming up in the slide. They show in Microsoft Access, Access actually has a tool that graphically shows you the connections. SQL Server has the same type of tool that shows you that type of connection. So visually, in Microsoft Access, you can see that the student number in table student ties directly to the student number in the grade table. And what's fascinating about that, there's also, you notice the little number 1 there, and the little infinity symbol, the 8 on its side. That indicates a one-to-many relationship. And in short, what that means is there can only be one student with that identity. I mean, you can even have students with the exact same name, potentially the exact same birth date. I've seen it, believe it or not. But regardless, there's still a unique entity, even if some of their information is the same. And that one student can have many grades, obviously, right? And then the other thing is that you can have many grades attributed to one class. And this one goes in the other direction, so it's a many-to-one relationship. Isn't that kind of interesting? But it's all graphically represented, and we will learn more as we go. Some of the underpinnings of all this, and we talked about this kind of in concept last time. Data is just the raw dump of information. And it's not information technically at that point, it's just data. When we organize it, then it has meaning, then it becomes knowledge, and we can really call it information. So when we type in some weird query into Google, and what comes back, well, it's all relative, right? Google organized it for us, thank you very much, but it doesn't mean it's relevant to what we're doing. So sometimes the way that you put it together is pretty important too. All right. They talk about different kind of database applications and how large they might be. And I think this is kind of a very subjective slide, frankly. You know, so like if you were maybe looking at sales contacts, you might only have a couple thousand, right? I'd say a lot of salespeople would be thrilled to have that many contacts, you know. Then they look at like patients or a CRM system, and then all of a sudden how many rows of information in all the tables? Yeah, it can be millions. And you can get databases that are huge, huge, huge. And then you can get databases that are really small. And it, you know, functionally they all somewhat work the same. The next kind of series of slides here talks about kind of the layers of working with a database. And I really want to make it clear to you that a database is not the software that runs it. Okay, so this is kind of a hard distinction to make. So particularly if a student comes into working with a database by using a product like Microsoft Access, what will happen is like, well, Access is my database. No, Access is the tool you're using to access the database. The database is actually the information itself, and all the relationships and other little components of SQL code and data that make up the total of the information. We then have layers. We have what we call a database management system, which is the layer that sits on top. For us, with this tool would be SQL Server, not the Management Studio. See the difference? So SQL Server is here. This is SQL Server for us. That's the database management system. That's how we're doing our queries. That's how we're pulling the information out. That's how we're connecting to it and administering it. In terms of the actual information, that's the stuff inside there. That, like that file that we restored from AdventureWorks, that was the database, that raw information. Then you have the application that sits on top, and when we're working with SQL Server, we're using SQL Server Management Studio to sit on top to allow that interface. So I hope that that's clear. And frankly, there's actually like layers to that too, right? Because that application ultimately really needs SQL to interface with the DBMS in order to connect to the data. So what you're going to see is layers that are happening. And in some cases, the database, the actual store of information, can be accessed using a number of different tools. And there are organizations where people write various front ends to connect to the same data. And that's okay, as long as your database can support it. All right. I think they're kind of breaking it down here. I think I kind of already mentioned all these. Any questions on any of these? I think that we covered those. So some of the stuff that the applications do: make forms, do queries, make reports, control the application itself. Yes, you can do all those things. Access can do all those things. SQL Server Management Studio can do them as well. When you work with Access, one thing that's kind of neat to do is you make a table, and then it's really easy to generate a form, right? And that's just a really quick little interface that's created automatically for you to enter in the data. That's not possible in a lot of other tools automatically, right? So if we were to build a web application, you guys are all web programmers, so if we were to build a web interface, we would actually build our form in HTML, right? And then probably combine it either with PHP or C# or JavaScript, or maybe all those, who knows, and then connect to MySQL to pull the information in and out of the form. But some tools like Access have a form tool built in. In fact, even Microsoft Excel has a form tool. Did you guys know that? So if you set up a table in Excel, there's a little form tool that mimics all the columns, and you can just type right into it. It's really not that big a deal. It's a very simple little interface. Another thing that these tools all share is the fact that we can run queries. So we'll learn some SQL, and then as you type in a series of SQL commands, the reason you're doing it is to pull back information from the database that's important to you, And then that output is typically going to be displayed in a table. So you query a table or a bunch of them to get the results of a table. So you query for data and you get more data. And then often, and you know, those of you that work out in the field with databases in any way, shape, or form, a lot of people that do database work often are tasked with creating reports. So some tools will also have reporting tools built in. With SQL Server, we have SQL Server reporting services that are attached to SQL Server. In Access, they have a report tool built in, but many of us maybe have worked in environments where you use a product like Crystal Reports, for example. Like back when I was first learning databases, that was the tool, right? So you take your output from all your queries or your tables, and then you take it to that product to make it look pretty. Because this looks nicer than this, right? Especially if you print it on a piece of paper. And there are people who have entire careers just doing database reports. It's just kind of a thing. Very interesting. All right, when we look at the database management system, that's the actual, like for us it's going to be SQL Server. That's the thing that has the capability to do these actual tasks. We issue the commands to the environment, and then the environment actually does the work. I don't functionally know how to arrange the ones and zeros in the computer's brain to create a database, but SQL Server does. All I have to do is say create database, give it a name, put it in a semicolon, press enter, and I got a database. Just like that. So the DBMS, remember, is SQL Server for us. What does DBMS stand for? That's one that definitely be on the test. Database Management System. All right? All right, so we're getting there, folks. We're rifling through this pretty quickly. All right, so it says here, the database self-describing collection of integrated tables. All right. Tables are called integrated because they store data about the relationships between the rows of data. And it's also called self-describing because it tends to store a description of itself. And we use this thing called metadata. I love metadata as a term because it's data about data. So in other words, when you are looking at a table, like, so let's say you're looking at the metadata for some of the tables in our database, and these might be those tables. So, oh, I got 3 tables, student, class, and grade. Oh, there's 4 columns, 3 columns, and what is the primary key? That doesn't really tell me a lot about what's in the tables, but it does give me a little bit of information about structure, right? So this is information about the tables. I can take that metadata a step further, and so if I'm looking at one particular table or a collection of them, it'll tell me all the fields, all the column names, the name of the table, and then the data type. So we do have data types here like we do in regular programming, although the structure of them is a little bit different, and we think about it in a little bit different way because when we are dealing with storing records, we often think about how big the data might be in order to save it as efficiently as possible. So here, for example, you'll see that there's a data type of text that says of the length in bytes of 25 characters, right? Because you guys realize it takes 1 byte, 8 ones and zeros to declare a character in computers. And that's, so when we say the length in bytes is 25 bytes, that means I can put 25 characters in there. Is that enough for a last name? Hopefully, unless you got one of those really long hyphenated names. But this is an overview. And then you can kind of keep that going. So a lot of times a database will have separate tables that just have information about the other tables. Almost kind of like an index or a table of contents in the book. Just to kind of give you an overview. And do you guys do that when you pick up a textbook? I mean, the first thing I do when I look at a textbook is to go right to the table of contents. Like, what's this book about? You know, oh, look, they're covering that. That's great. I would cover that too, you know. So that's an example of metadata. The next thing they do is they go into this little discussion about what Microsoft Access is, and it says it's a low-end product, you know, and it's not really that low-end, but most serious professionals would stay away from it. However, it is important to note that Microsoft Access is powerful enough where you can do a complete database system. And not only that, if you've got the whole thing figured out, all your forms and your reports and your tables, all your stuff is all up to snuff, you can actually package it as an executable file right inside of Access. It also has the capability of publishing the stuff directly to the web, too. So it's not really that low end a product, but it is considered a lightweight database product in comparison to like Oracle and SQL Server and DB2, for example. All right. So they talk about how Access works, all the tools that are available to it. And I want you to just take a really quick look at the slide here. So you got users, they can work with data entry forms, reports, and queries. And then Access will do all this stuff, right? This is what Access is doing. So it's kind of acting as all of it. And this is kind of interesting because the DBMS is also Access, and this is where it gets a little confusing, because Access is a front end, and it's also a back end. The data still sits separately in its own structure. Where it gets weird is when you start looking here, and so when we say enterprise class, now we're talking about something like SQL Server, right? And SQL Server, of course, would be responsible, and I'm kind of disappointed you don't have this like highlighted. SQL Server would take care of all this stuff and allow for SQL, but the database management system is actually SQL Server itself. SQL Server Management Studio handles the high-end stuff. So it's kind of separated into two layers. So the question then becomes, can I use a different product to talk to SQL Server? And the answer is, absolutely, why not? It's just a matter of connecting it. So like one thing that you learn when you're a programmer, and you guys maybe have learned this, whether you're using Java or JavaScript or whatever, to talk to a database, whatever program you're writing, all it needs is the connection script for how to connect to that database. And then you can work with it. Then you just need to know how to type in the SQL commands to have them translated. All right. You have also this goofy little chart showing you where, increasing power and features, increasing difficulty of use. All right. So Microsoft Access, way on the bottom end, easy to use. And you know what? Fine for a lot of things, honestly. When we teach you guys how to do database stuff, we tend to teach you at this level here. So we teach this class obviously around SQL Server, but you'll notice, the company that creates this product is Microsoft, right? And then you notice MySQL, even though it's the big open source database product, and there's a clone of it called Maria database, by the way, that a lot of websites are now using instead. They're functionally equivalent. But that's an open source product from Oracle, so that's their lightweight free database. So it is by Oracle. So notice way on the high end though, we have Oracle database. That's still probably like the most powerful product out there. But IBM DB2, which we do teach in our software program here at Gateway, is way up there too. And what makes these kind of unique is how the architecture of how they're built. And what I mean by that is like IBM DB2 needs to run an IBM operating systems on IBM hardware because they have a little bit different approach to how their operating systems execute content. And so on an IBM system, all content is put into what they call containers before it's able to be treated as an object. It has some weird kind of like legacy features to it that stem from really old IT structures, but at the same time, as a result of that, makes it super flexible, and it's why there's still AS400 systems and really old databases that are up, like running banks and stuff that are still up there and running. That same ones they were using like 4 or 5 decades ago. I think it's fascinating because for as much as things have evolved, they're kind of still the same. They talk about the different types of database design, and I think they kind of like summarized it here, but let's just really quickly rifle through these slides. And I think this is fascinating because you might be put in the situation as a programmer from time to time that you're going to face a variety of these different kinds of scenarios. Every once in a while, as a database person or a programmer, you will have to build a database from scratch. So you have user requirements and all that kind of stuff. And what they're showing you here is if you're building a database from existing data, where are you getting that data from? Chances are you probably have a bunch of it laying around. Like maybe you have the output of some other system perhaps, or maybe you just have a bunch of spreadsheets and you're like, well, I got all these spreadsheets. Heck, it makes sense to make a database out of this, right? And that's often what happens. You're not usually, and it's unusual to say, well, you know what, I'm going to build a database. And then type all the information from scratch. Usually you have the information and it's like, now what do I do with all this? That's typically the scenario, so that's why they point that out here. So either gathering up stuff that you have and then you build a design, or you take something that's already functioning, extract a bunch of data from it that you don't necessarily need to be in that environment, and build a database out of it for a different functional reason. And that way the information you have in the new database doesn't interfere with the existing system. Because ERP and CRM systems, what's ERP? Enterprise Resource Planning. We haven't really talked about it, right? But that's a type of large database system. And then CRM is Customer Relationship Management, right? So who might use a CRM system? Salespeople, for example. Who might use an ERP? I don't know, somebody like Gateway that does a lot of different things. So I don't know what our CRM or ERP systems are here. Brent? Okay, so Colleague is the ERP, and it's called the Lucian's the front end. Right. Okay. So we just taught students how to hack their databases. Then they go into how you import data, and when you bring in data, then you have to start looking at, like, does it make sense to keep it all in one table, or does it make sense to split it? The other thing that happens if you are building from scratch and you don't have pre-existing data. Now, I've done this a few times. In fact, when I first learned how to do databases, I used a guided tutorial where I did exactly this. So I thought about, okay, I have to build a student database. That was my thing. Student grading and registration system. That's what I built. It was my first database project, right? Self-taught. And I had to build the tables. I had to link the relationships. I had to build all the data entry forms, all the reports, so like report cards and class rosters and really goofy things like that. But I thought it was a really good exercise. But you need to have some sort of a thing that you're working from. So there's a comparison here to like building a programming project. So the planning aspects of it in particular. So you have to think about, what is it? Why am I doing this, right? You don't just build a website just because. You build it for a reason, right? You do the same thing for a database. And what is it that we need out of that system? What is it going to do for us? Why are we going through the trouble of doing this? And the real classic example for this scenario is where you're building a database system to replace a paper-based system. And so if you are in the habit of, let's say, I'm trying to sign you guys up for my baseball team, here's a form, sign up, right? It's a piece of paper, and then what do I have to do, type it all in? Well, maybe. But what if I can create a form where you can just do it online? And then it goes right into my database. It just saved me a whole bunch of time. Now I have more time for lunch, right? And as silly as that sounds, those are the efficiencies that you look for, right? And that's how you justify expenditures in IT, is like all the time it saves you. If you're ever in a situation like this, and I've done this a couple times too, where we had existing databases and then you try to make it into something new. In some cases, you're even combining them. And there was a day with databases, especially for primitive consumer ones, where we did not have relational databases. That's really kind of interesting. So, well, how do I query them then? Like if you know any database stuff. But the relational database thing really took off pretty heavily in the 90s as all the personal computer stuff was starting to take off. And there were a lot of really cool products that came out at the time to help with that. But I remember often most databases were really just big fancy spreadsheets with front ends on them. That's all they were. That's it. And if you think of it in that capacity, so a spreadsheet could be a database? Absolutely. One single spreadsheet can be a database. And often when we do web applications, so look at you guys as programmers, we might only need one table for our website. You might not need 50 tables linked together. So that's okay. Doesn't matter how simple it is. In terms of the jobs, like who handles what. This is really interesting. I like where they put the divider on this when I looked through this, was reading through it in the book. So notice that if you were somebody that really was a database administrator, okay, and if you're really interested in that, I would encourage you to follow that path because you can get very well employed. You go everywhere from the SQL statements through the server infrastructure, like SQL Server or whatever, and right down to the data repositories. That's your job. And the farther to the right you exist within that structure, the more money you tend to make. Right? And once again, using that analogy, you know where the bodies are buried because you know where the data is all stored. And database people often are so critical to organizations that organizations have a really hard time replacing them. Really hard time. Now, as a knowledge worker and programmer, which is really where we fit in, it is important to understand how these aspects operate, right? And we do toy with them. But for us, it's really the higher end language or tool that we're working with. What is our need to extract information to make that application work? And so we usually know high-end languages and a little bit of SQL. We're able to do the queries. And now there's all these new tools out there too. So as you start to venture into some of the new front-end development tools for web, they have like a tool called GraphQL, by the way. And they have all these new NoSQL databases. Recognizing that web programmers maybe don't need a really fancy relational database. And those tools often are very graphical, and you can build queries with drags and drops and not really have to know the query. And there's also many other tools that sit at this level. So if you get to the point where you're learning C#, for example, and you do database interactions, typically you're working with a technology called LINQ, L-I-N-Q, or if you're working with, say, like with Ruby on Rails or something like that, all of them will have what we call database abstraction layers, where you can do simple things with code that then writes the SQL statements for you, which is kind of interesting. But in traditional programming, I'm thinking like Java, some C#, that's kind of a hit or miss, JavaScript, PHP, and I think like Java and PHP in particular, we type SQL commands directly into our code and then inject them into the server to bring the information back. So that's where we sit in this world. So I think that's a really, really cool graphic. They go through a couple of other things here in terms of what's in each chapter. So I think this is kind of a nice little overview. How far we get into the book really is going to depend. I will be happy if we can get up through chapter 7 or 8. And we'll see kind of where it goes from there. And that's really a lot to pull in. Some of these chapters will extend over weeks because there's just so much content. I mean, even chapter 2 probably has like 100 pages of stuff in there just to read. That's a lot. Right? It's a lot to kind of master. So I'm in no hurry. The most important chapters are the early ones. So those are the ones I really want you to kind of wrap your head around. I might even say that chapter 2 might be the most important one overall. So that's important to note. show a little bit of history here. And oh, this is wonderful. I love this slide too. I was looking at it before. Because we look at like some of these ways that we would store data in the past. And really, you know, they didn't really have databases. So like, they actually thought of file management in an operating system as a database in the old days. And the interesting thing is there is a database that runs your file system. You know, that's one of the key databases in the operating system, is keeping track of where all your files are. So why is it you can bring up a file window and you got a little search thing where you can search for files? Well, because it's indexed. That's why. Some early database systems, and I love looking at these. So from 70s through 1980, they had some of these. I've never worked with any of those. Has anybody worked with any of these?
I didn't work with them, but I was a computer operator and dealt with
Okay, well, good. It's when we got into the mid 80s where we see some of the really key developments starting to happen and products that are still around. So you see Oracle came into play and DB2 on the IBM platform. They were both relational database systems. And so I think that's pretty important. When we got into the personal computer era, we started to see some of these products, which were products that were not always relational, but were really important foundational products. So DBase 2, well, and 3 and 4, I remember those in the workplace, and those are basically flat file systems with front ends. Microsoft Access has been around for a while and really has evolved quite a bit. But at the same time, like Microsoft had like the professional, like the precursor to SQL Server was HexPro, and that was kind of their front end system. And then we got into what I would call more the modern era of computing. You can see how we moved into the full Oracle database, the one that made them millions and millions of dollars, and a couple of other things. As we look into the, I would call the modern era, and I would say everything after 95, because that's when the web was around, we started seeing databases put on the web, because somebody was like, wow, it would be great if we put our database out there and we can query it right from a browser and pull in results, and then people don't have to call us on the phone, that kind of thing. What a miracle that was. So you can see that the back end stuff there, so you see IIS and Apache, those are web servers, right? Those aren't necessarily databases, but the languages we use to interface with the databases, PHP, .NET, and Java are the big three. And in the web program, we teach all three of those. So, it's cool to see some things change, some things stay the same. Then we saw the rising of open source databases, so MySQL probably being the big one, but Postgres is pretty huge too. As we moved a little farther into the future, you started to see these things like XML, and the big replacement for XML now, not that the other ones aren't important, is now we're moving everything over to JSON format. And if you guys have studied your JavaScript at all, you know that XML is our parent markup language for all markup languages. So HTML, for example, is defined with XML, but really XML is designed to be a database structuring language with a hierarchy. And JSON, which is a JavaScript object notation, is really serialized JavaScript information in key value pairs. It's not the most efficient way to transmit information, but at the same time, so many technologies use it, it's become huge. Some of the other things that you see listed here really kind of go way beyond the scope of the class, but there is this huge thing that's happening out there right now, and it's called the Big Data and NoSQL movement. And these technologies here are largely driven by those. So some of these we do teach in the program. I know that I think Christian's teaching MongoDB both in Web 2 and in the React and Angular classes, if you take those. JSON is kind of like the preferred serialization format now for most applications. And then people that are in the data analytics program, I don't know if we'll ever get to use Hadoop, but my hope is. But Hadoop is like a big clustering conglomeration tool for linking together different types of databases and getting data from all of them at the same time. And that's where we get into the big data field. So everybody's keeping data on us. How do they link it all together and have it mean something? It's really kind of freaky. You know, like if you do a search on the phone, I forget what search my wife did the other day on the phone, but she was pulling back a result for school, and that's not quite what you're looking for. And I think that I don't know, throw machine learning in there, and before she could even type it, right, all she hit was an M in the search thing. Somebody's listening. I'm like, I guess that's what happens when you click I agree, right? You're allowing them to listen into what you're saying to help your search go a little faster. And while that's kind of an intrusion, it's also kind of a convenience. All right. Almost done, and then we'll take a break. All right. So the one thing that we will learn about is the relational database model. And yeah, there's a name that goes with it. So E.F. Codd, back in 1970, thought this through, and he built it on top of mathematics. All the good ideas come from math, folks, right? But he really put that together. So this concept of linking tables together, we can attribute to a specific person. So it's not that new, right? So we're 50 years in, right? Right? So don't tell anybody. Right? But it also indicates that there's still stuff that you can create. And once again, like the big movement right now is the NoSQL thing is really gaining ground, and working with big data and how we manipulate, you know, really rich and diverse sets of information. All right, just about done. I guess we're done. All right, so let's take a 5-minute break, and then we'll come back and we're going to start digging in to some other materials.